So as in this the flow chart, we see that the calling of a function original value. If we want to change the original value, then we use call by reference. And if we does not want to change the original value of the parameters, then we use the call by value. When we call by value, then in the function argument have always been passed by value. This means that when calling a function, what is passed to the function are the value of these arguments on the moment of the call, which are copied into the variables represented by the function parameters. For example, int x is equal to 5, y is equal to 3, and z, and then we call the function z is equal to addition x, y. Here addition is our function, and x and y are our called actual parameters, or we call these x and y as parameters. So in this case, when function addition is passed 5 and 3, these 5 and 3 are copies of the variables values of x and y respectively. These values 5 and 3 are used to initialize the variable set as parameter in the function definition. But any modification of these variables within the function has no effect on the values of the variables x and y outside it, because x and y were themselves not passed to the function on the call, but only copies of their variables at the format. So when we define our function, we write int addition, and into the parentheses we use two parameters that are int a comma int b. These two parameters int a and int b take the values of x and y arguments from the function call, which is written as z is equal to addition 5 comma 3. So the call passes two values 5 and 3 to the function. These correspond to the parameter a and b declared for function addition. Again, call by value. What is a call by value? In call by value mechanism, the call function creates a new set of variables in stack and copies the values of the argument into them. In call by value method, the call function creates its own copies of original values sent to it. Any change that are made occur on the function's copy of values and are not reflected back to the calling function. Here is an example of call by value. In the coding, first of all, we declare a function name swap with 0 return value and with arguments int x and int y. Into the main program, first of all, we declare two variables a and b and pass a is equal to 7 and b is equal to 4, two values to them. Then we print the original values of a and b on the screen. After displaying the value of a and b on the screen, we call the function swap, and we want to swap the values of a and b. After swapping the values of a and b, we want to display the swapped value on the screen, so we use cout the value of a after swap is a, and the cout the value of b after swap is b. Then we program as void swap int x and int y. So here int x and int y are you call by value. These x and y takes the value of a and b from the main function and after taking the value of a and b, the value 7 and 4 are stored in respectively in x and y. So into the body of this function we write int z, we declare another variable. We use this variable in swapping the values of x and y. So first of all we store the value of x in this variable z, then we store the value of y into x, and the variable y is equal to z mean it takes the value of x stored in z. Now after swapping the value of x and z, we display the values on the screen. The screen shows that swap value a is x and swap value of b is y. Output of our program, the original value of a is displayed as 7, and the original value of b is displayed as 4. Then we call our function, and into the function we swap the value of 7, a and b. After swapping the value of a and b, it displays us swapped value of a is equal to 4 and swapped value of b is equal to 7. Then control goes back to the main function, and into the main function after calling the swap function, we again write two lines to display the value of a and b. When these two values a and b are executed, uh, it shows on the screen the value of a after swap is 7 and the value of b after swap is 4. So in this program swaps the value of two integers taken by the user using a swap function that perform the swapping task. The swap function accepts two integers from the main function as shown in the prototype. Before we do the swapping, we simply display the values of variable a and b so that we may know the state of the variable, means whether they undergoes a change or not. The statement swap a comma b is an example of call by value where the function swap is called by value. Here variable a and b are actual parameters and their values are passed while invoking the swap function, meanwhile calling the swap function. The function definition of swap shows int x and int y. These are called formal parameters and they receive the values of variables a and b passed from the main program. Inside swap function, before we swap the values of variable x and y, we print their values on the screen. Once the swapping is done, the values of variable x and y are again printed on the screen. Then the control returns back to the main function and the values of variable a and b are again printed on the screen. So we note uh, from this program is that the values of actual parameters a and b are passed to the formal parameter x and y. Any change done on the formal parameter do not change the actual arguments as we see in the output. So no change the original value after call the function by using call by value method. So second is call by reference, argument passed by reference. In call by reference, original values is changed or modified because we pass reference addresses. Here address of the value is passed in the function, so actual and formal arguments share the same address space as we see in our previous slides where we explain reference variable. Hence, any value changed inside the function is reflected inside as well as outside the function. To gain access to its arguments, the function declares its parameter as reference. In C++, references are indicated with an ampersand mean and operator and unary operator following the parameter type. So, for example, we have a function named duplicate and with no return types, and when we define this function we write it as y duplicate, and into the parameters we use int and a comma int and b comma int and c. Here we write and between int and a so that we make a as a reference of another variable. Similarly, b is as a reference of another variable and c is a reference of another value. The another variables are used in calling the function where we write duplicate x, y, and z. In fact, a, b, and c becomes aliases of the arguments passed to the function call x, y, and z. And any change on a within the function is actually modifying variable x outside the function. Any change on b modifies y and any change on c modifies z. That is why when in the example function duplicate modifies the value of variable a, b, and c, the values of x, y, and z are affected. This is call by reference. In call by reference mechanism, instead of passing values to the function being called, reference or pointers to the original variables are passed. In call by reference method, the called function accesses and works with the original values using their references. Any changes that occur take place on the original values are reflected back to the calling function. Let's see. Before going to the example, in this case we pass the addresses of a variable rather than value. We use AND operator for this purpose. To call by reference we cannot pass value, we have to pass memory addresses of variable. We already discussed these things in another slide. So this is the code. In this code, first of all we declare our function swap. We write it void swap int. Now instead of x and y we use int and x comma int and y. We make x and y as a reference. After that we write our main program. Into our main program we use two variables a and b and pass 100 and 200 values respectively to these two variables. After passing the values to these variables, we display these values on the screen. We write before swap value of A is equal to A, before swap value of B is equal to B. Then we call our function. To call our function swap, we write swap A comma B. Here A and B are our arguments. Now when this function executed and completes, then it in the main program we want to display the value of A and B again, and we write it as cout after swap value of A is equal to A, cout after swap value of B is equal to B. So here we write our function. In the function definition of swap, we write it as void swap int and x, int and y. Now these x and y are a reference of the values of A and B, and into the body of this function we write int temp. We use an temperature, we declare a variable with name temp. Then we use this variable temp is equal to x. Here we save the value of address x into this variable. Then we put y into x. We write x is equal to y. Then we put x into y. We write y is equal to temp. The output of this program is look like as when the above code is compiled and executed, it produces the following result. Before value swap value of A is equal to 100, before swap value of B is equal to 200, after swap value of A is equal to 200, after swap value of B is equal to 100. So we clearly see that in this example, the original values A and B also change with the change of formal parameters. Okay, there is another pass by pointer or address. Pass by pointer or address is another type of data passing that will be covered later under the section on pointer variables. Note it clearly that it is often mistakenly termed pass by reference in some C textbooks because the actual pass by reference passing mechanism is only available in C++. Pass by pointer or address requires use of the address operator and the pointer difference operator static to be covered later. An example of pass by pointer. Most of the textbooks say it call by reference method, but it is not a call by reference, it is called by pointer. So in this example we see that in declaring a function with a void swap int x int y, and in between int and int x we write a static. Similarly in between int and y we put a static operator. This static operator makes x and y as a pointer. Then into the main program we similarly use two variables a and b and pass values 7 to a and 4 to b. Then we display the value a and b on the screen. Then we use pass by reference call of the function which is swap, and instead of a and b we write and a and b, where a and B are used as a reference. After this program, we display the value of swapped A and B on the screen. Now, in our swap function, we write void swap int static x a comma int static y. Here x and y are as a pointer, not as a reference. So into the body of swap function, we write int z. Z is equal to static x, mean we store the address of x into variable z. Then we store the reference address of y into x. We write static x is equal to static y. Then we store the address of z into the pointer variable y. We write static y is equal to z. Then we show the values of a and b on the screen. After program, the output of this program is look like as original value of a is 7, original value of b is 4 as written in the main program. Then function is called, and when this function is called, the values are swapped and swapped value are displayed as swapped value a is 4, swapped value b is 7. Then control goes back to the main program, and into the main program, after calling the program, we again display the value of a and b. So it shows the value of a after swap is 4 and the value of b after swap is 7. Here we clearly see that the original values are changed because we pass the address rather than the value of the function. Here is another example of call by value. In this program, first of all, we declare function void function int x int y, and into this function we store 11 into the x and 22 into y. Then we call this function into the main, and we write the main function body. In the main function body, we write int a is equal to 10, b is equal to 20. Then we write cout value before calling, and we display the value a and b as you see in the right corner, right below corner of the screen. It shows us value before calling a is equal to 10, b is equal to 20. Then we call the function a and b. So here we did not place any appercent operator, mean and operator before a and b. So when we write fun a and function fun into a and b, it means we use call by value. When this call by value function called, control goes to the function void fun int x int y, where x and y are formal parameters, and these parameters take the values of a and b from the main function, which is 10 and 20, and into this function we store another value 11 into x and another value 12 22 in y. So after completing this function call, when then control goes back to the main program, as in the main program we display the values of a and b after calling. So in the output we clearly see that when we cout a and cout b, it shows us on the screen value after calling a is equal to 10, b is equal to 20. So there is no change in variables when we use call by value. In this example statement, one is passing the value of a and b to calling function fun. Fun will receive the value of a and b and put it into x and y respectively. X and y are value type variables and are local to function. Any changes made by value type variables x and y will not affect the value of a and b. So, for example, if we declare two variables a and b and store value 10 and 20 into them respectively, and let's see, we say that A has an address 48252 and B has an address 24686. Then we use two variables x and y, and when these two variables x and y receive the values of 10 and 20, they replace these values 10 with 11 and 20 with 22. So there is no change in the addresses, only change in the values. So x and y will not affect the value of a and b. Same example for call by reference. In call by reference, first of all, we use void fun int static x in static y. Instead of static, use and operator. And into the body of this function, similarly, we replace x with 11, y with 22. And into the main program, we write int a is equal to 10, b is equal to 20. Then we display the value of a and b, and in the lower right corner you see the output of these lines as values before calling a is equal to 10, b is equal to 20. Then we call our function by reference, and when we call our function by reference we use AND operator. When we use AND operator and into the function, control goes to the user defined function, that is void fun int x int y, and into this we replace the value of x is equal to 11, y is equal to 22. Now note that as this is called by reference, so the instead of value, the address is now changed. When address is changed, the value of a and b is automatically changed. Then control goes back to the main program, and into the main program, after calling function, we display the value of a and b again, and in the output we see that values after calling a is equal to 11 and b is equal to 22 is now changed. In this program, statement 1 is pass the reference of a and b to the calling function. Function must have pointer formal arguments to receive the reference of a and b. In statement 2, static x and static y is receiving the reference a and b. Static x and static y are reference type variables and are local to function. Any changes made by reference type variable x, static x and static y will change the value of a and b respectively. Graphically, we see that we declare two values a and b, and we place value a is equal to 10 and b is equal to 22. And we say that a is equal to address, a has an address 48252 and b has an address 24686. Then we call our function, and in our call of function, now instead of value, the address goes to the variables or parameters of the function, and x and y receive the, instead of values, the addresses. X receive the address 48252 and y receive the address 24686. Then we store value static x is equal to 11 and static y is equal to 22. When we store static x is equal to 11, it means it changed the value 10 in the address 48252 with the new value 11. Similarly, static y change the value 20 at the address 24686 with the new value 22. Now when we display A and B on the screen, instead of displaying 10 and 20, they shows us new values 11 and 22. So here is call by value versus call by reference. In call by value makes copy of actual parameters. Call by value passes copy of contents. Call by value original variables. Contents do not change. During program execution, value parameter manipulates data stored in own memory spaces. In call by reference, instead of values, call by reference passes addresses of actual parameters. Access original variable contents via addresses. Original variables contents do change, returning more than one value, and it is more efficient than call by value. So let's have a scenario. What if we need to perform some same calculation of different data types? The best solution is we use functions. For example, we write a function to calculate the square of a integer or square of a variable. So we write a function int square, we name it square of integer, and we pass it a variable. Then we multiply this variable with its own value and we return this value back to the main function. Similarly, if we want to calculate the square of double values, then we write another function double square of double and double number, and we multiply this double number with itself to calculate the square of a double value. Into the main program we use a number int I number mean integer number is equal to 10 and double number 10.10. Then we call our function. We write cout the square of integer is. While writing the cout, we call our square of integer function ino and we pass a value ino to it. And in the next cout statement, we call our second function, that is square of double, and we pass it a variable dno. It displays us the output as the square of integer is 100 and the square of double is 102.0.